But that intelligence could take a different shape. You may have seen the famous film by Andrei Tarkovsky, another Russian reference, called Solaris, based on a book by Stanislav Lem, in which the whole planet was intelligent. And so some mathematicians have suggested that a Solaris-like intelligence would not be able to discover numbers. Because why? How would the Solaris intelligence discover numbers? Because there's only one. Here we can count people, 1, 2, 3, 4, 5, 6, and so on, right? We're used to discovering things by counting, discovering numbers by counting. But a Solaris is only one. So some people suggested, well, perhaps such an intelligence would have a different approach to mathematics in the first place. What I would like to argue is that's not necessarily the case, that actually there would be a way for Solaris-like intelligence to discover numbers. So, you see, it looks so appetizing that I actually decided to bring the real ones. I didn't want to torture you with that picture. I wanted actually you experience them. You see, but there is a problem with this because you see, they all look a little different, like this one is a bit more red than this one and so on. So when we say that they're the same, I say 1, 2, and so on, it's a bit of a cheating if you think about it. And in fact, if you teach kids this thing, they will tell you, why are you counting them as if they were the same? And they're not the same. You can have some. So in mathematics, actually, there is another way to discover numbers. There is another way to discover numbers, whole numbers. We call them whole numbers, 1, 2, 3, 4, 5, and so on, right? We call them whole numbers, or sometimes they're called natural numbers. There is another way. And the way we discover them is by what we call winding, which actually is very easy to explain. And my dentist would be really proud because he's always complaining that I don't do enough flossing, which is true. But I'm trying to get better at this, so I'm actually going to do it right now. No, I'm joking. But I'm just going to... It may not be the best place. But, okay, but I just want to show you something. You see, when we have a floss, okay? When we have a floss, and then I try to wrap it around my finger like this. So what do I do? It's 1, 2, 3, 4, right? I'm actually discovering numbers by wrapping this string, that floss, around my finger. And in fact, it's better than strawberries because there is no such thing as a -1 strawberry. At least I've never seen it. I bet it tastes awful. But with the floss, it's very easy to get negative numbers. You just wrap the floss around in the opposite direction. You see? So this way, you actually discover not just positive whole numbers, 1, 2, 3, 4, 5, but you discover all integers, all whole numbers, positive and negative. And there's a picture which illustrates that, you see. Now, so this is very clear, right? But you can also think of this as a circle wrapping onto itself. So you see, you have a circle, and you can think of the circle wrapping onto itself. So if you have an intelligence in the form of a circle or a disk, that would be a sure way for it to discover whole numbers, simply by realizing that it can wrap onto itself. Now, what is less obvious to a non-mathematician is the fact that a sphere can actually do the same. A sphere can also wrap onto itself a number of times, and there are two possible orientations, just like a circle being wrapping this way or that way. So this is something which we can't really draw a picture of, And so I would argue that the Solaris-like intelligence, which is essentially like a sphere or like a ball, because it's like a planet, right, would be able, in fact, even though it's one and only, as far as it knows, it would be able to discover numbers by imagining the possibility of wrapping onto itself. And so you see, so to me, this is a good indication of two things. First of all, that the first answer that comes to mind, that, okay, so it's only one, therefore you cannot get numbers and so on, it actually may be the wrong answer. And it is the wrong answer because, in fact, there is another way. And second, that mathematics allows you, kind of opens the door to some unexpected worlds and unexpected phenomena, which we don't even imagine. We actually could be connected to something we do, but we don't even realize it, you see. So that's the depth and that's the beauty of mathematics that I'm talking about. You know, people ask, why do we need to know? Why do we need to learn mathematics? Why do we need to learn this stuff? I think the answer is twofold. That first of all, mathematics is now everywhere around us. All the technological advances that we are enjoying, like a laptop, like a smartphone, the internet, etc. All the algorithms which are hidden, which are kind of secretly behind so many things and kind of secretly controlling us sometimes, I feel, they're all based on mathematics. So this is something which is very much sort of strikes close to home. But I think what's also important, and we should never lose sight of, is the kind of, I want to say, mysterious aspect of mathematics. It's a great mystery. It's a great mystery. It's a great detective story, in which we still don't know who done it, But we'd like to know. We'd like to know. That's our essence as humans. We want to know the answers. We want to understand. We want to push the veil over the unknown. And mathematics, I think, is this secret world which contains some of the most important secrets. It's a portal, if you will. It's a portal into the deepest understandings of the world, of our consciousness, of the oneness, perhaps, that we don't experience sometimes in the day-to-day life. That's why it is important